In this video, I'd like to show you how you can use the steps state, plan, solve, and conclude to solve an estimation problem. Let's go ahead and read our scenario. An online goods wholesaler would like to estimate the average time it takes a robot to locate an ordered product and bring it to the packaging/shipping department in their large warehouse. From a random sample of 40 customer orders, it takes the robot an average of 3.6 minutes to do the job. Let's go through the steps state, plan, solve, and conclude to calculate a 95% confidence interval for the true population mean. We're going to assume sigma, the population standard deviation, is equal to 5.2 minutes. So the first step is state, where we should state the question of interest. So what would we like to do? Well, we would like to estimate the average time it takes the robot to locate a customer product and bring it to shipping/packaging. Now, in most academic problems, this step isn't really needed because it's already asked in the question. However, in real life, in any sort of practical sense, we're going to have to state our question of interest. So this is an important step to practice. The next step is to plan. In this step, we want to define our parameter that we're looking for. So the parameter in this case is equal to mu, the population mean. This means that we're going to do a certain type of confidence interval. The confidence level we want to use will be equal to 95%, and the type of procedure we're going to be doing is a Z procedure. That's because we're going to do a mean, and we know the population standard deviation, which we'll talk about a little bit more in a second. All right, the next step is we want to solve the problem. So in the solve step, we want to first check conditions before we actually do any calculations. So we want to check conditions for this Z procedure. The first condition, and always one of the most important, is that our sample is obtained using a random mechanism. So is our sample random? If we read back through the problem, we can see that it says from a random sample of 40 customers. So yes, we have a random sample, so check mark. The next condition is that either our sample size is large or that we know that the population is normally distributed. Well, in this case, we don't know if the population is normally distributed, but it doesn't matter because n is equal to 40, which is greater than 30, and that means that the central limit theorem can kick in, and so this condition is met. The last condition is that we know our population standard deviation, sigma. And in this case, we do. It says assume sigma is equal to 5.2 minutes. So we're good to go. We've checked our conditions. Now we should solve for the confidence interval. So a Z procedure confidence interval is x bar plus or minus a Z critical value times the standard error of sigma over the square root of n. And in this problem, our sample mean is equal to, if we scroll up and look really quick, 3.6 minutes. Sample size is 40, and our standard deviation was 5.2. So x bar is equal to 3.6 plus or minus a 95% Z critical value, which will be 1.96, times sigma, 5.2 over then a sample size of 40, the square root of that, which is equal to then 3.6 plus or minus a margin of error of 1.6115. I always recommend that you go out to 4 decimal places before you round. This means that we have a 95% confidence interval between 3.5888 minutes and 6.8115 minutes. Now in my write-up or my conclusion, I'm probably going to round that down to fewer decimal places because it just doesn't make sense to go out 4 decimal places for minutes. All right, so the very last step is to conclude. So in our conclusion, we want to do a couple things. We want to use context, and we want to state the confidence level that we used and make sure that we use units when we do our upper and lower bounds. So if we're using the sample write-up, we'd say the 95% confidence interval, and I'm just going to abbreviate confidence interval as CI, estimates the average time it takes the robot, and this is the context part, to do its job. And maybe I would elaborate on that a little bit more if this was more formal. Is from 3.6 minutes, and I'm going to just kind of abbreviate that a little bit from the original confidence interval, to 6.8 minutes with a best guess of 5.2 minutes on average. I just wanted to include my point estimate in there as well. All right, so this is how you can use the 4-step process to solve a confidence interval problem.